Okay. So for the next topic is design and construction of road embankment on soft ground. Okay, the construction of the embankment over very soft compressible alluvial deposit, okay, for example, clay, glacier, is unavoidable for infrastructure work, especially road and railways. Okay. The choice of construction method in this formation is not only governed by direct costs, but also on the long-term maintenance cost, duration of completion, and cost benefits. Okay. So this is a typical type of embankment, okay, which is built, okay, for example, if it is built on a soft area, okay, so we may discuss on in terms of the what will be the design consideration, okay, and what will be the methods to improve, okay, the condition of the soil, okay, when we build this kind of embankment. Okay. So, okay, this is a brief explanation in terms of the difference between fill and embankment. Okay, so fill refer to a volume of earth, earthen material that is placed and compacted for the purpose of filling in the hole or depression. Okay, so while for the embankment refer to a volume of earthen material that is placed and compacted for the purpose of raising the grade of a roadway or railway above the level of existing surrounding ground surface. So either we using a preloading either the embankment considered as a preloading, or we also include additional surcharge. Okay. So I think in terms of design, we need to check when we design for the embankment. Okay. So the first one is the bearing capacity. The bearing capacity occur when the maximum stress exerted by the embankment field over the foundation is greater than the bearing capacity of the foundation soil. Okay. The settlement during the construction may be a problem. However, settlement may occur during the service period will be a big problems. So we have here a short term, okay, and also for the long term. So the embankment should be designed and constructed so that any continuous settlement within 50 meter from structure approach or within 100 meter remove from structure after a period of 5 years is not. Okay, this is based on the design, guideline for the slope design. Okay, especially for the embankment. If not mistaken, 7 years. Okay, 5 or 7 years. Okay? The one that we have discussed previously. Okay? The stability. Okay, so this is based on stability of the embankment should be ensured during the after construction. Actually, stability is not the main issue. Okay, because if we compact the embankment properly and what we call as uh, the degree of the slope, or we are using 1 to 2, okay, and we compact well, so there will be no problem in terms of the stability of the embankment, the slope, bearing capacity, and also the settlement. Okay. So stability, mode of failure, okay, internal stability, and also for the overall stability. So internal is more related to, for example, for this kind of failure, okay, while for the steepest is for the overall stability. Okay. So the design stability of embankment on soft ground is 1.3. Okay. Okay, rotational stability. Okay. So this is not a big issue for if we construct the proper improper way. Okay. However, we have a problem, especially on the soft clay formations. Okay. So, for example, then in order to increase the stability of this embankment, so most of the designer using what we call as a geotextile, okay, on before they construct for the embankment. Okay. So lateral sliding, horizontal movement of field driven by active wedge. Okay. So reinforced tension developed in the plane of the reinforced. Okay. Again, geotextile also has been used. Okay. To reduce this kind of lateral sliding. Foundation extrusion, lateral extrusion of foundation due to settlement of field. Okay. So again, the same method that can be used is by using the reinforcement method, where normally they use the textile as well. Okay. So the solution to this mode of failure is to reduce the settlement by making the base stiffer. Okay. I guess the common type is by using the geotextile. Okay. So the other way might be they use micropile or any foundation approach to gain a stiff base. Okay. So procedure for design of embankment. Okay. This section will briefly list down the overall procedure necessary for design of the embankment over soft clay. Okay, the procedure are as follows. Okay. Determine the embankment field height. Okay. Settlement analysis. Design of surcharge height. Stability analysis of the embankment. Okay. So okay. So this is the net field height. Okay. So in order to cater for the what we call as for the settlement, PT is the total settlement. Okay. So and to gain the finished road level. Okay. So in that case, we need to what we call as apply or put a preloading or a surcharge, okay, on the top of the embankment. Okay. And then after total settlement take place, so we can obtain the targeted finish road level or rail level. Okay. So we need to familiar with the term of NFH, okay, TFH, FRL, okay, for the embankment design. Okay. Before carrying out embankment design and selection of the most appropriate construction method, the following issues should be considered: the boundary of the embankment, influence of the embankment on adjacent structure, service slopes and drainage, earliest construction start date and completion date, tolerance on settlement and differential settlement of the proposed development or structure, rate at which embankment fill material can be placed, availability of fill from other part of the site, the availability of alternative material, cost analysis and implication of the ground treatment proposed, future maintenance. Okay, so this is all the issue that should be considered, okay, when design for the embankment. Okay, so the V2 type of loading. Okay, the first one is single loading. So normally a single loading when we design for for a not for a not a too high of embankment or finish road level. It will cause an immediate increase in total stress, and if the filling is so rapid such that dissipation of pore water pressure can take place or insignificant, the stability of embankment will rely on the in situ undrained shear strength SU of the subsoil. Okay. Actually, I'm not pretty sure in terms of what will be the minimum height for the single stage loading. Okay. But the common type method, the common type of construction is using the multi-stage loading. Okay. But the disadvantage, it require a longer time. Okay. The advantage of the multi-stage is the subsoil is allowed to increase in strength as construction took place under the embankment load. However, the rate of increase in loading needs to be limited so that the ratio of the load to the available strength of the subsoil is within the acceptable safety. This method also requires longer time of construction. So determination of embankment field height, EFH. Okay, determine the net field height, which is the related to the finish road level. Okay, is the finish road level minus with the existing level. So that is the net field height. So first preliminary estimation of the total settlement. Okay, as a crude guide, the following percentage can be used. So we need to determine what will be the soft clay thickness. Okay. For example, if less than 5 meter, so the total settlement as percentage of NFS is around 15 to 20%. Okay. Then by knowing this total settlement, okay, so we can get an idea on the estimation of the embankment field height, okay, which is the total of the net field height and the total of the settlement. Normally for the soft clay, okay, if I'm not mistaken, for very soft clay, the value for the strength is less than 25 kPa. Okay, to represent for a soft clay soil. Okay, so then carry out settlement analysis to obtain the representative total settlement, which include immediate settlement, primary consolidation settlement, and secondary consolidation settlement. Okay, so this is the three component, okay, for the settlement. Okay. So normally secondary consolidation we are not consider or ignore in the calculation of the EFH. Okay, this is because secondary consolidation cannot be totally removed during constructions. Okay. So after obtaining the total settlement from step 4, okay, correct the embankment field height as in step 3. Okay, so the difference should be less than 5%. Okay, so then obtain the correct field height. Okay, it's important to calculate the EFH so that stability analysis can take into consideration the loading from the field to compensate the settlement. Okay, so this is a procedure. We try to find how they calculate for this type of step, okay, and then include. So we understand the procedure, but it's better to have a calculations. Okay. Okay. So then we have here settlement analysis. Okay. So we have what we call as immediate settlement or initial settlement, primary consolidation. Okay, and also the last one is secondary completion. Okay. So total settlement okay, is the PI, PCN, PS. Okay. So selection parameter, okay, plot all the borehole result, obtain correct existing groundwater level, okay, install standpipe to monitor because water in borehole after drilling can be misleading. Okay. So standpipe is to monitor for the groundwater level. Okay, but by using the piezometer, okay, so we can determine the pore water pressure. Okay. So compile all consolidation parameter into following plot for all borehole or in zone. Okay. So this is to get the consolidation characteristic. Okay. So select the, so this is and then uh, we can plot for the all these parameter with the depth. Okay. Select the design line of consolidation parameter. Okay, need to be reviewed. Okay, just to look on the pattern. Okay, obtain the undrained Young modulus. Okay, this is to estimate for the immediate settlement. Okay, for example, if you are using the SPT, okay, so this is the Young modulus value and times with n value. Okay. Or we are using the undrained shear strength correlation, then we may times to 200 to 60. So lastly, the correct EU can be obtained from the CIU test, which is the triaxial consolidate undrained test, consolidate isotropic undrained test, CIU. But this is a common calculation. Okay. But some of the reference book they using 100 something, okay, to obtain the Young modulus. But for this case is very high, 2000 to 3000. So construction of the embankment will cause settlement to take place in the subsoil after and during and after filling. So this phenomenon is more obvious for embankment constructed over soft clay due to consolidation process. Okay. Therefore, it's necessary to evaluate the magnitude and the rate of settlement of the subsoil supporting the embankment so that the settlement in the long term are within the specific limit and should not affect the serviceability of the railway track on the top of the embankment or roads as well. These are ways to ensure stability. So an interactive process is required in the estimation of settlement because the extra field are required to compensate for settlement. Okay, so this is why we uh, 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 add the uh, surcharge of the uh, embankment, okay, to compensate for the what is in previously. The calculus not should consider, okay, because it's not a load. So settlement calculation, usually assumption of one-dimensional consolidation are generally valid for embankment. So that is the easy way, okay, to determine the settlement. Okay. For clear layer or larger thickness, horizontal flow or pore water pressure may be more significant, and one-dimensional theory tends to underestimate the rate of consolidation. Okay. And normally we use the what we call as a software, okay, because the common calculation for the one-dimensional consolidation, okay, to the two-dimensional consolidation can be solved numerically, okay. So okay, when a load finite dimension is the resulting settlement can be conveniently divided into three stages. Okay. So this is initial, primary, and secondary. Okay, so this is the calculation. This is the formula for the initial settlement. Okay, 1 over EU. EU is the Young modulus. I is the influence factor. Okay, so we don't discuss in detail. So I guess you may learn this initial settlement under different subject. Okay, so Q is the load, apply load. So to determine the Q, so we may refer to this Austenberg chart, okay, to get the what we call as the Q, okay, and the Q actually should base on the height or on the level of the soft clay, because this formula is applicable for a soft, sorry, for clay formation. Okay, so if you want to determine the settlement, initial settlement for sand, so we need to use another approach. Okay. Okay, then traffic. Okay. But required to for the slope stability. Okay. Traffic surcharge. Okay. But the slope stability, I guess, is also not being considered unless if we I guess also it's not been considered because it was due because the traffic is considered as not non-permanent load. So for the sustainability also we will not consider for the traffic from the vehicle, the traffic load from the vehicle. Okay, so this is consolidation settlement. So this is yeah, actually we have three type of equation. Actually four type of equation. Okay, so either we want to use the volume of compressibility MV, okay, or we want to use the reloading, coefficient of reload and coefficient of compression, coefficient of recompression and coefficient of compression. So if we are using the CR and CC approach, okay, actually we have three conditions, which is the first one, the normally consolidated, okay, And then we have over consolidated, and the over consolidated have two type of condition. Okay. If the pre-consolidation is greater than the effective vertical stress and the loading, so I guess we use, okay, sorry. Okay. So if the PC is a pre-consolidation, okay, is greater than effective stress. PC is greater than uh, uh, the increment of the loading plus with the effective vertical stress. Okay, then we have another condition if the PC is less than delta sigma plus sigma prime. Okay, so okay, yeah, this is yeah, OCR over consolidated or consolidation ratio. Okay, when the PC, okay, over effective stress. Okay, when the PC is greater than the effective vertical stress. So normally OCR is greater than OCR is greater than 1. Okay. So if the OCR is less than 1, we consider as a normally consolidated. Okay. Normally consolidated, okay, where the condition, where the PC, where the pre-consolidation is equal with the effective vertical stress. Okay. So this is equal to 1. Okay. So for the OCR is greater than 1. Okay. So for example, if PC less than delta sigma plus sigma, so we may use this equation. Okay. So if PC greater than sigma and sigma prime, okay, so we may use this equation. Okay, but this is the example that I refer to GNP, GUI and partner. Okay, but to discuss in detail in terms of the formula for the consolidation settlement, okay, so we need to refer to the reference book. Okay. So then for the NC, if the PC is equal, then NC is the PC over effective stress is equal than 1. Okay. So then we use the equation of CC. Okay, CC over 1 plus E naught log P over effective vertical stress. Okay. Delta sigma. Okay. So how to differentiate between CR, determine what will be the PC value from the odometer test. Okay. So with time, the excess pore water pressure dissipates as drainage occurs and the clip undergoes further settlement due to volume change as stress is transferred from pore pressure to effective stress. Okay, the rate of volume change and corresponding settlement is governed by how fast the water can drain out from the cliff under the induced hydraulic gradient. The loading of the embankment shall be based on the EFH, no surcharging, or GFH. Okay. One-dimensional primary consolidation settlement can be estimated using the expression. Okay, so it depends on the type of the condition. Either is normally consolidate or over consolidate. Okay. So normally, when we apply, when we fill the area with with a certain height of embankment, Okay, so normally we refer to OCR value. Okay. Okay. So this is the what we call as the value, the notation, okay, that we may use, okay, where this is the CR, why this is the CC, okay, why this is the CS, okay, the swelling index, uh, uh, what secondary. This value will be normally is be used for secondary compression. CR and CC normally being used is used for the primary consolidation. Okay. So that's why MV is not very popular, okay, compared to the CR, CC and CS, because the MV is from the EP. Okay, while this is E log P scale. Okay, for the MV, the pattern will be like this. Okay, so we have two MV and the range of pressure. So that's why it's not a very popular to be used, okay, to estimate for the settlement compared to the CC, CR and CS. Okay. So in order to calculate the actual feed height, okay, properly, okay, the EFH or GFH, okay, ground field height, earth embankment field height, different pressure can be applied to obtain different settlement for each borehole or zone. Okay, the result are used to plot the settlement over net field versus the actual field thickness. Okay, so the total settlement in this plot should include immediate settlement and consolidation settlement. From the plot, the net field, the total settlement actual field thickness can be obtained. Okay, so this is from the plot obtained from the, for example, from the site, okay, to determine the actual field thickness. Okay. So then there will be a secondary compression. Okay, even after complete dissipation of acid formation, then the effective stress are about constant. There will generally be further volume change and increased settlement, which is termed as secondary compression. Okay. So normally, okay, this is due to the rearrangement of the soil particle. Okay. So for example, for the initial settlement, okay, due to a rapid loading, so there will be what we call as settlement happen. Okay. While for the consolidation settlement or primary settlement, okay, is due to the dissipation of pore water pressure. Okay. Then after we let it after the 100% of primary consolidation settlement completed, then the particles start to rearrange or readjust its position. Okay, so in that case, the secondary consolidation start. Okay, however, the value is not very significant compared to the what we call as to the uh, primary consolidation. Okay, but it is better for us to include in the calculation. Okay, for example, if I'm not mistaken, the problem in Changi Airport, okay, due to the area uh, is reclaimed area. Okay, so during the design stage, so it doesn't include the secondary compression. Okay, so when the completion of the project, so they found that a lot of settlement happened. Okay, so it is due to the secondary compression. Okay, this is what I learned from one of the NUS, if not mistaken, NUS professor. Okay. Okay. So either we use this equation or we can estimate based on this relationship from the natural moisture content to obtain the secondary compression. Okay. So the rate of consolidation, okay, so this is to determine how long the process of consolidation uh, take place. Okay. So TV is the time factor, okay, which is depend on the UV. Okay. UV is the consolidation degree. Okay. For example, normally 100% of consolidation, we just refer to 90% of UV, okay, where the TV is equal to 0.848, okay, if I'm not mistaken, of TV, okay. So from there we can estimate how long the process of consolidation, okay. After we know what will be the CV, okay, CV is obtained from the odometer test, okay. So we obtain from the odometer test. While the HD is the height of the clay layer, okay. But it depends on the drainage system. Okay. For example, if it is a double drainage where the water can move from the top and also move to the bottom, okay, so the H will be divided into two. Okay. So we divide into two. Okay. So if a single drainage, for example, if this is a bedrock, okay, so and or impermeable layer, so it's allowed to move one way. So H no need to be divided with two. Okay. So from there we can estimate how long the process of consolidation. Okay. For example, it can be up to 15 years. Okay. Of the process. So that's why they're using the method to accelerate the consolidation process is by using the vertical PVD lah, prefabricated vertical drain. Okay. So the coefficient of consolidation CV can be obtained from the meter. Okay. The another reliable way CV, okay, by using the MV. Okay, MV also actually we obtain from the odometer. Okay. The use of the field K, okay, will be give a better representative scale on uh, K is the permeability, okay, of the scale structure of soil structure. Okay. Since the permeability and compressibility of the soil reduced with the increase in effective stress, the value of CV should be modified to reflect the state of the stress over the period during which settlement rate are being calculated. So method for embankment construction, okay, modification of embankment geometry, okay, reduction. Okay, this is method of the construction, okay, in order to get what we call to to gain a better stability. The first is untitled chapter, okay. Another one is excavation and replacement of soft soil. Okay. But the maximum depth is 4.5 is variable in terms of cost and practicability. Okay. Okay. Okay, so this is an example of the process of E and R, okay, excavation and replace. So when we replace, okay, up to 2 meter, okay, so it can reduce the settlement to 60%. Okay. Okay. So it can reduce the settlement up to 60%. However, it require a lot of cost, especially when we want to move the unsuitable material to another area. Okay. Okay, so this is the vertical drain. Okay. Okay. And commonly been used, okay, no more than 30 meter, okay, under SPT 7 to 10, okay. So that is the application of the vertical drain. Okay. So then we have a temporary surcharging. Okay. Normally we include the surcharging and the vertical drain and use it together. Okay. So this example, okay, when we apply, okay, for the surcharge, okay, so we can reduce, okay, or we can re, uh, service life settlement. Okay. Sorry, okay, by applying the surcharge, okay, so we can get a proper, get a better settlement uh, value, get a higher settlement value. Okay. So then it can exceed the service life of the embankment. So then geotextile stone column is a part of the embankment construction. Pile embankment. Okay. So this is another way to improve the stability of the embankment. Okay, construction monitoring and control. Okay, so during the construction, we should monitor for the settlement. Okay, from the vertical, horizontal, and also to determine the development of pore water pressure. Okay, so by using the piezometer, so we may monitor for the increment of the pore water pressure. Okay, when we apply the load on the top of the soft ground. Okay. So this three type of monitoring should be used for the embankment. Okay. Okay, so embankment stability check during construction. Okay. So this is based on Matsuo stability plot. Okay. So during the construction, we should check, okay, the stability, okay, based on the lateral displacement and also based on the field height. Okay. So when we start to increase the what we call as the height of the embankment, okay, So we need to check the stability, okay, which is where is the area of the zone, okay. For example, green zone, so embankment field can continue, okay. So when it exceed to yellow zone, okay, so this is supposed to be green, not blue. Orange, red, this is orange, this is yellow, yellow, orange. Okay. So this is blue, okay. Supervising engineer to inform design office and embankment filling can continue. Okay, for area with PVD, the embankment filling rate reduced. Okay. So then if it need to red, okay, supervising engineer to stop the embankment filling immediately and inform design office. Design office to review the instrumentation data and advise on next course of action. So this is based on the height and lateral displacement. Okay, there are some methods that they rely on the development of the pore water pressure. Okay, so it should consistently similar with the pore water pressure development. Okay, for example, if this is a typical for pore water pressure. Okay, so when it start to fill, okay, so there will be what we call as a increase of little bit increase of pore water pressure. So then we should let it stable, okay. Pore water pressure, okay. So I'm not sure in terms of percentage, okay. So it would not exceed certain percentage. 2%. Okay. Red zone, okay. Yes, yes. If you refer to this diagram. Oh, okay. Then there will be two methods, okay, to determine the measure the settlement, okay, in this slide, okay, which is the hyperbolic method and Asoka methods. Okay.
If you are doing reclamation at sea,
Ah, sorry.
so can we use this approach if you are doing reclamation at sea?
Okay, so this is the disaster charge. Okay, okay. Tak dengar lah.
Doctor, can you hear me?
Hello?
Hello, doctor?
Ah. Ah, tak dengar, tak dengar.
Hello, doctor?
Ya, ya.
Okay.
Intan lah.
Ya, saya. Sorry, internet saya problem sikit.
Ah.
Can we use the same approach, doctor, kalau kita buat reclamation at sea? As in,
Reclamation field. Okay, to
reclamation
yes.
at sea.
Ah, ah.
Okay.
Um,
Or is there any
but for the surcharge,
for the surcharge?
I guess only for the settlement.
Okay.
Yeah, we may use the same approach with the embankment. But the embankment is more related to the stability, and which is because we construct on a certain what we call a certain type of shape.
Oh, okay,
Okay?
okay.
True. But honestly, I also doesn't have any experience for the reclamation work. Okay. But I guess in order to gain what we call as the field height, so we can use the same approach, okay, based on the settlement.
See, okay. Okay, doctor.
Okay. So surcharging is is to subject the ground to higher pressure. Okay. So this is how to design for the surcharge. Uh, the one that we discussed previously is the embankment field height. Okay. Then we add with the surcharge. Okay. Okay. Determine the long-term PT. Okay. Determine the duration for surcharging. Okay. Obtain the total settlement versus time. Okay. Based on the figure. Okay. If the okay, if the vertical drill are used, this method can be used with the minor adjustment for the vertical spacing and more rapid rate of settlement. Okay. Okay. So later on, we can remove, okay, for the surcharge, okay, after we obtain a certain height, after we obtain the targeted field height. So this is the estimation uh, uh, for the settlement based on different field height. For stability, short term, uh, and also long term should be checked. Okay, two type of method potentially to be checked: circular modified or non-circular. So at the end, we may use the numerical or any software tools to determine the factor safety. Okay, so we can check first by using the SU. Okay, and then we can check after that for the long term by using the CNP. Okay, okay. So normally I will check for both. Okay, for the short term and also for the long term. Okay, so for the short term, factor safety is up to 1.3. Okay, and while for the long term, normally we use for 1.4. Okay, JKR use 1.5. Mistaken for the long term. Okay. 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 Instability analysis of the embankment should be the height of the embankment should be embankment height if no surcharging. Gross field height if surcharging. Okay. At least 10 kPa surcharge loading machine on the top of the embankment at team pressure during the stability analysis. Okay, we just apply, for example, if this the embankment. Okay. So in the software, so we put additional of 10 kPa, okay, to cater for the machine, okay, and also for the traffic as well. Okay, yeah, correct. So the traffic should be considered in the stability, okay, not during the uh, settlement analysis. Okay. So this is for the traffic. Okay, this is the guideline for the parameter of the well. So the fee value is 28 to 30. Okay, so that's why if we design for example, for the slope area, if we design 1 to 2, so there will be no problem in terms of this failure at the slope area. Okay, so because it is it's less than 28 to 30. So if we compacted well. three type of method modeling. So okay, total stress effective analysis, okay, undrained shear strength analysis. Okay, so this is explanation of the total stress where we use the CSU. Okay, so effective stress, okay, where we obtain from the CIU or CID. Okay. So undrained strength method, it is based on the SU over what we call as the effective stress. Okay. So okay, this is the factor safety. Okay, so this is the more explanation on the factor safety, which is we already discussed in our factor safety issue. Okay. So selection of ground treatment. Okay, so they note three type, okay, of priority. Okay, so we can use the first priority, okay, counterweight berm, okay, should have sufficient right of way, okay. So we need to check the border for the embankment, for the road, for the development area, okay. So that is the limitation of the counterweight berm. Okay, partial soft soil replacement should be limited to not more than 4 meter deep if possible, okay. So number 2, okay, stage construction with or without vertical drain, okay. Geosynthetic reinforced high strength geotextile, okay. So the last one is the pile embankment, okay. So if the priority number 2 doesn't work, okay, so I guess this is much more costly, okay, compared to the priority 1 and priority 2. Okay. Okay. So that's all for the embankment. So the last one uh, on the instrumentation. Okay. So actually I have shared this slide in the e-learning. Okay. So we may go as fast as possible. Okay. So for the instrumentation monitoring, okay, uh, there are three types of important thing that we may consider during the instrumentation work. Okay, the first one is the climatic condition. Okay, for example, the rain gauge, radar amount of water in cloud, and satellite prediction tool. Okay, so now for the common tool that we are using, the rain gauge. Okay. So then we have a hydrological parameter, which is that we are interested on the piezometer, groundwater level and pressure. Okay. Time domain reflectory is the soil moisture content. Okay. And if you want to study on the unsaturated soil mechanics, so we may use the tensiometer, okay, which is to study on the soil suction. Okay. So then for kinematic parameter, which is on the movement, okay, inclinometer, tip meter, okay, extension tip meter and inclinometer, we want to monitor for any lateral movement. Okay, extension meter to monitor for the vertical movement. Strain meter to monitor for any movement and the vertical and horizontal. Survey marker, and then we also have a GPS to translate into velocity or acceleration. Okay. So this is a common type of monitoring method. Okay. So we have a road settlement gauge, okay, deep leveling datum, okay, piezometer, standpipe, okay, the difference between piezometer and standpipe. Standpipe is used to monitor the groundwater, while the piezometer is monitored to the pore water pressure. Okay, but both we can get the groundwater level. Okay, so inclinometer, extensiometer, and then we have a settlement marker, permanent settlement marker. Okay. So settlement permanent marker normally we use with the leveling method. Okay, so correlation with rainfall and activities. Okay, so the measurement work. Okay, so we can get all this reading. Okay, and compare. Okay, with the, for example, with the rainfall. Okay, at the same time we monitor the inclinometer reading. Okay, and also with the piezometer value. So this is a site to study on the unsaturated soil mechanics, okay, by Prof. Azman Kasim. Okay, so he has installed all this device, okay, at the what we call it at the UTM. Okay, so he used this tensiometer, okay, to monitor for the suction. Okay, at this hilly area. Okay. So then the pore water pressure, okay, determine safe rate of fill, predict slope stability, design and build for lateral pressure, design and build for uplift pressure, monitor the effectiveness of the drainage scheme. So the method piezometer, vibrating wire piezometer, pneumatic piezometer, and standpipe piezometer. Okay, so for the lateral deformation, okay, evaluate the stability of slope and embankment, determine the need and timing for corrective measure, verify the performance and safety of the structure such as retaining wall and embankment. So the instrument used inclinometer and road extensiometer. Okay, so the last one is the vertical deformation. Verify the soil consolidation is predict the adjust and the final grade of embankment, verify the performance of engineering foundation, determine the need and timing for corrective measure. So this is the method that normally being used: settlement cell, magnet extensiometer, okay, sondeck, settlement point, root extensiometer, and horizontal inclinometer. Okay. So I have only several experience using this piezometer, standpipe, okay. Inclinometer doesn't have any experience. Okay. Extensiometer, I have experience. Settlement point, okay. So I don't have any experience using the inclinometer and road extensiometer, okay, to measure for the lateral deformation. Okay. So three main embankment slope mechanism, okay, rotational stability, lateral sliding, and bearing capacity. So this is what we have discussed previously. Okay. So construction of embankment. Okay. So this is typical of embankment. Okay. So this is the the loading. Okay. The factor safety value. Okay. So based on the removal and replacement method. Okay. So for example, if 2 meter height, so what will be the load? Okay. Increased by 4 and 8. Okay. Then calculate for the settlement. Okay. So this is a typical type of what we call as a table or table for the embankment construction. Okay. Okay, so this is the type of instrumentation, okay, that been used, okay, where they install the piezometer at the center, okay, and the inclinometer, okay, at the side of the what we call it, of the embankment. Okay. So this is uh, settlement marker. Okay. Okay. So this is also the piezometer where they monitor at the embankment structure as well. Yeah. So settlement marker, vertical movement at the embankment field. Okay, for the foundation, road settlement gauge, inclinometer, piezometer, water stand pipe. Okay. Conventional survey installed a monitoring point using total station or differential GPS, determine rate of movement. So this is only for surface measurement only. Okay. So this is settlement marker normally being used under a surveyor. Okay. Okay. So we can get the surface movement only, okay, by using the settlement marker. Okay. So if it is positive, so it is a heaving. So if it is negative, so it is a settlement. Okay. So I have a project, okay, at one of power plant in Malaysia. Okay. So we want to investigate the settlement, okay, occur at their place. Okay. So then we use the settlement marker, okay, to get the surface movement. Okay. And then we also use the piezometer, extensiometer to monitor for the movement at the soil, inside the soil. Okay. So this is road settlement gauge, okay, installed before the embankment start to construct. Okay. Okay, so this is the reading, okay, for the road settlement gauge. So they measure what will be the settlement on the foundation due to the filling process. Okay. So the blue one is the fill height. So they increase the fill height. So what will be happen to the settlement? Okay. Okay. So when they increase to, for example, to 2 meter, okay, so what will be the value for the settlement here? Okay. So then they plot with the time. Okay. Road settlement gauge versus magnetic extensiometer. Okay. So another way is by using the extensiometer. So they use a spider. So for example, we want to look on uh, for example, any level or any height. So we install this plate magnet. Okay. So if any settlement happen, so this magnetic indicator, okay, will get the value for the settlement. Okay. So for example, we install for the first day. Okay, this is after we this is we install when we bore the sample, when we bore the soil. Okay. So then we install this casing. Okay, and the casing has a flat magnet. Okay, then when we want to monitor, we get first the initial reading. Okay, then after a certain period, okay, so we can determine for the any movement, okay, in inside the soil. Okay, water standpipe used to measure groundwater table level in the slope, does not measure pore water pressure. Determine the change in the groundwater level. Okay, so normally they use the distometer to get the, or laser distometer to get the height of the water. Okay. Or they use this kind of approach, okay, to determine the height of the soil, the height of the water. So piezometer standpipe. So okay, so this is piezometer standpipe. Okay. So we may determine at a certain level of height by using this piezometer to get the pore water pressure. Okay. So from there, we can monitor the pore water pressure development. Okay. So this is the common pore water pressure. Okay. And then we may monitor after we do a filling. Okay. So what will be the development of the pore water pressure, okay, due to the filling. Okay. So then we need to allow to the pore water pressure to become in up to a normal condition again. Then we start to fill for the next level. Okay. I'm not sure in terms of percentage, how many percentage, okay, that allow us to um, continue for the filling process. Okay. Okay, water standpipe versus piezometer standpipe. Okay, so this is a difference between the construction of the water standpipe and the piezometer. Okay, this is inclinometer. Okay, to look for the lateral movement. Okay. Okay, groove for torpedo. Okay. So from there they can get the value for the lateral movement. Okay, so then this is the type of the graph produced from the inclinometer result. Okay, plotting monitoring data. Again, I didn't have any experience on this type of instrument. What monitoring data to be collected, when monitoring data to be collected, how to terminate monitoring work. Schedule of instrumentation. Okay. So in terms of frequency, okay, during filling work up to formation level, the reading should be recorded after each change in loading, not to be less than 2 weeks per 2 times per week. Okay. Next 4 weeks after completion of filling works, every 3 days. Next 12 weeks, 1 trip per week. Next 12 week, 1 trip per 2 weeks. Okay, so this is the schedule uh, uh, to record, okay, for the instrumentation. I guess for the embankment, okay, when the time that we start to do a filling, right after the filling, so the most critical time is during that condition. Okay, so this is Asoka. I guess you may learn in the another subject, okay, to use the Asoka, which is I not discuss on this example. Termination of settlement monitoring work. Okay, so field data prediction primary settlement. Okay, so when it reach the predicted primary dimension, which is the under the 90% of consolidation, so we can start to terminate for the settlement monitoring. The groundwater and pore water pressure, the monitor has been stopped. Stage of construction, pore water pressure development. Okay, they start to do the filling, so there will be increment of pore water pressure. Yeah. So when the times increase, okay, so for example from 94 to 95 and to 96, so the pore water pressure has been reduced. Okay, this is for the horizontal deformation. Horizontal deformation monitoring. Profile after failure, profile before failure. So the blue one is the profile before failure, while the green one is the profile after failure. So we can find that there are movement from the base reading, okay, to the 16th of November. Okay, so this is example for the inclination value. Okay, so construction monitoring, settlement marker, the maximum surface heat over maximum vertical surface. Change in pore water pressure. So we can start to we can start to do the filling. Okay, after we reach this ratio. Okay, so change in pore water pressure over increase in embankment pressure should greater than 0.7. Maximum lateral movement over maximum vertical movement greater than 0.5. Okay, if I'm not mistaken, this is the value that should be referred before we carry out for the filling process. So for the equation number 1, okay, where there's a maximum surface heat our maximum vertical settlement should greater than 0.2. Okay. Well, this is for the pore water pressure. Okay, 0.7. Okay, so if not reach up to 0.7, so we can continue for the filling. Okay, so the same with the last one. We can continue for the filling is if it doesn't reach 0.5. 0.2, 0.2, 0.7 and 0.5. Very soft. So, okay. So I skip this one. So this one, ground formal laboratory test. So this is more on laboratory value, laboratory test value. By laboratory test. Okay, so I've skipped this one. Okay, so that is the type of the instrumentation that normally being used in the embankment construction. Okay, so it's already 10:24. Okay, so I guess I stop my lecture. Okay, for tonight. Okay, sorry for there are some explanation that I'm not familiar. Okay, so that's why I skip for the laboratory part. Okay, so with that, I end my class and then I will upload the video. Okay, I will try to upload the video at tomorrow morning. Okay, so thanks, and then so we can still have we can communicate by using the WhatsApp. Okay, if you have any further question. Okay.
Okay, thank you.
Okay. So, okay, bye. Assalamualaikum and good night. Okay.
Assalamu alaikum, Prof. And good night.